Hello everyone. In this video, I will be discussing the cases which were introduced by SystemVerilog, and those are unique case, the priority case, and the unique0 case. So let's begin with the unique case. So unique case is a mixture of full case and parallel case. So what do you mean by full case and parallel case? So in a full case, all possible values of case expressions are explicitly handled, preventing any unwanted latches. Whereas parallel case means no multiple case items overlap, avoiding unintended priority logic. So to understand it better, let me introduce you with an example. So I will write a module of very simple ALU, and it will have one output Y, three inputs. Those are A, B, and opcode. I will mention the direction of each signals. And our opcode will be of 3 bits. So let's begin with our combinational logic. I will use always com procedural block. So to write a unique case, you just have to write unique keyword before case. So that's it. It is very similar to the previous structure of case. Then it is followed by the case expression, and here I want the variable opcode to be my case expression, and I will also end case. Now I will begin with my case selection items. So I will write 4 case selection items. So my first one will be 1, and if the opcode is 1, then it will perform the summation of the sum between A and B, and it will assign it to Y. In the second opcode, I will select, let's select 0 for the first opcode. In the second opcode, I will select 1, and here it will perform the subtraction between A and B and assign it to Y. In the third opcode, I will select 2, and if this opcode is selected, it will perform the multiplication between A and B and assign it to Y. Finally, in the last opcode, I will select 4, which is 100 in binary. And if this happens, then it will perform the division between A and B. So this concludes our ALU model, and I will first go ahead and check for any possible compilation error. Okay, there are no errors. So it is very simple. Here what will happen, the unique case keyword ensures that exactly one of the case selection items matches the case expression. So it generates warning. So let's begin with our test bench. So I will mention the variables. I will instantiate my DUT. Now I will write one initial block which will continuously monitor the value of y, and I will write my another initial block to provide stimulus to the DUT. So let's begin. So for this example, I will just concatenate the entire thing, and then I will provide the 5-bit value. So A will get 1, B will get 0, and for my opcode, I will select this one, the multiplication. So I will write 0, 1, 0. First, I will check for any possible compilation error. Okay, the code is just fine. And I will go ahead and simulate the code. Okay, we are getting 0, which is the correct value. And it is the multiplication between A, which is 1, and B, which is 0. So what happens if we choose any illegal opcode that is not mentioned here? So let's go ahead and change the opcode to be 3. Let's save the code and run it. First, let's check for any compilation error. Should show right here. Okay, so let's go ahead and run the code. It shows warning, and in the warning you can clearly see right here that no condition is true in unique priority if else if case statement. So that's the thing, that if any illegal opcode which is not mentioned here as a case selection item is selected, it will show a warning which is clearly stating that the given opcode or the given case selection expression does not match any of this case selection item. So this is the quality of unique case. So there is another case which I would like to discuss, and that is unique zero case. So unique zero case ensure that the case should be parallel. So it means that all the case selection items should be mutually exclusive to each other, and there should not be multiple matches. So what it basically means, there should be one match at most. So for the unique case, it was it was exactly one match, but for unique zero case, it should be at most one match. So as per the definition of unique zero case, if there are no matches, then the code will show no warning because the requirement is that at most there should be one match. So what happens if we save the code with the modified unique case to unique zero case, and here as per our opcode 3 it is not matching any of the case selection item. So what will happen? So let's go ahead and simulate the code, and let's find out whether it shows any warning or not. Okay, so this time we are not getting any warnings because we have changed the unique case to unique zero case. So if even there are no matches with any of the case selection items to case expression, there won't be any warning as per the definition of unique zero case. But what happens if there are more than one matches? Because as per the definition, there should be at most one match. So let's go ahead and modify the code a little bit. I will change this to 10 and I will also change the first one to 10. So let's find out, will this show any warning or not? I will also change my opcode to 10, which is equivalent to 2 in decimal. And let's save the code and simulate it. So we are prompted with a warning, and it clearly mentions here that the case statement is not unique. So yes, so if there are uh, more than one matches in the case of unique zero case, you will be prompted with a warning. So that's all about unique case and unique zero case. So let's move on to our last category, which is priority case. So unique case was the mixture of full case and parallel case, whereas unique zero case performs just as a parallel case. So what about priority case? It performs as a full case. So it ensures that at least one case selection item matches the case expression, otherwise it generates warning. So basically priority case, which you can write like this, it basically means there should be at least one match. Otherwise, the simulator will show warning. So there can be multiple matches. It is possible. And the case selection item will be selected on the basis of the priority. So what are the uses of that? We will find out with the help of an example. But for this example, to know whether it stands up to its definition or not, we will be running it with with an illegal opcode, and there is no 3 right here. So I will save the code and run it. to check whether it shows any warning or not. Okay, as you can see right here, it just show warning. No condition is true in the unique priority if else case statement. So yeah, it is true that if there are no matches, then priority case will show a warning. So there should be at least one match in case of priority case. So to understand the usage of priority case better, let me write another example. It will have one output and four input. The output will be of 4 bits and the inputs will be of single bits. I forgot to mention the data type here. I will begin with my combinational logic. So I will write the keyword priority. So for this example, I will be using a different thing. So this thing is called reverse case statement, and I will help you understand it. So as my case expression, I will write a literal value of 1. So first I will complete the case statements and the case selection items, and I will explain it. So if A is high, then Y will get so in the reverse case, what will happen that the case expression is 1, which basically means that if either of these are high, then their case selection item and their condition will be selected. So there is a high possibility and an obvious possibility, I will say, that there will be multiple case selection items high at the same time. So what will happen? Which one of these will be selected? Since we are using priority case here, so it is fine because as per its definition, there should be at least one case selection items matching, and which means there can be multiple case selection items matching. So let's say if A is high and if B is also high. So on the basis of the order, A will be selected over B. So hence it is called priority. So let's go ahead and model a test bench for this design, and it will help you understand it better. So this is just a reverse case. So whichever is high will get picked, and it depends on the order. So I will mention all the variables. So I will first write one initial block to monitor the value of output. First, let's check for any compilation error, whether I have made any typos. Okay, it's fine. Now I will write another initial block to provide the stimulus. So I will just concatenate every input and I will just assign them. So let's give a value of 1 and B a value of 1 and C and D a value of 0. So 1, 1, 0, 0. So let's find out which of these will be selected. And as per our definition, we are expecting to pick A, in which Y will get this value 1. So let's go ahead and simulate the code. But I forgot to instantiate the DUT. Okay, never mind, I will do it right here. So PRI, let's name the instance DUT, and I will just do the wildcard code declaration. Okay, first let's check for any compilation error. Now let's go ahead and simulate the code. Okay, as you can see right here that this particular case selection item is getting picked and it is getting priority over B. So I will run two more simulation checks just to ensure whether uh, we are finding the correct usage of priority case. So what I will do for my second simulation run, I will make A equals to 0 and I will make the remainder of the case selection items to be 1. So we obviously know that B will be get picked. Still, let's find out. We are expecting a decimal value of 2. Yep, we got 2. So in my last simulation check, so I just want to make it sure that only one of the case selection item is matching. If none of them are matching, that it will show a warning. But we have already looked in our we have already saw that in our previous example. So I will just make this 0. I will make C equals to 0 and I will only let D is equals to 1. So we will get 4, not 4, it is 8. I'm sorry. So let's go ahead and simulate the code. Yep, we got 8 right here. So this was all about the definition and the usage of unique case, unique0 case, and priority case. These three cases were introduced by SystemVerilog and they were designed to replace the cases which were used in Verilog. Those are case Z, case, and case X, which I have already discussed in my earlier video. So in most of the SystemVerilog designs, you will find every engineers using these ones. So I hope you find this video useful. Thank you so much.